So basically we are covering stacks, right? And the question, so basically you already know this is stacks, so think, right? But this question, right, I want you guys to solve it as usual from the basics, from brute force, and then slowly build up your intuition as to where stacks will be used. Okay. So let's say you're given a list of daily temperatures T. Sue, have you done this question before?
No, Ankur, I have not.
So it's lead code 739 daily temperatures.
Yeah, I just opened it.
Okay.
I haven't done it either, so it's
Awesome,
gonna be new
nice.
for me.
Yes. So basically the question says you're given a list of temperatures. Let's say T equal to 73, 74, 75, 71, 69, 72, 76, 73. Just hold on, let me. Okay, so your output should be basically you're given a list of daily temperatures, return a list such that for each day in the input, so each day in the input, you need to return how many days you have to wait till you get a temperature which is higher. Like for 73, you return 1 because 74 is the higher temperature. For 74, you again return 1 because 75 is the higher. For 75, you return 1, 2, 3. So you have to wait for 4 days. For 71, you have to wait for 2 days. 69, you return 1, right? And 72, you return 1. Then you have 0. And similarly for 73, you have 0. Is that clear?
Yeah.
Okay. So given a list of temperatures, for each so these are the temperatures of each day, and for
Right.
each day given, you have to return how many days you have to wait to see a temperature which is wait, let me see. Until a warmer temperature, for example, a temperature which is higher than 73, right? So this will be 2, and if there's no warmer temperature than so 76, you add 0 into that place, and for 73 there is there's no answer, so you return 0. Is that clear?
So Ankur, for the 69, why say 1 instead of 3?
Because 69 the
The
next
next day is 72,
72.
right? So it's higher.
Oh,
So
it's a
one
higher.
Not the
day.
highest, but the next warmer. Immediate day which has a temperature above the current one. So similarly for 71, 69 is lower, 72 is higher, so you show 2.
I see. Okay, got it.
74 is 1, 75 is you have to wait till 76. So this is 4 days. 73 you have 74. 73 there is no warmer temperature, so you add 0 into the list. I mean you put 0. 76 also you put 0. So that's the question for you. And the temperature has to be more than 73. Not even if it's 73, you still return 0. I mean, if you don't count it actually, right? People join. Okay, so let me just say hi to everyone. So Deven, so just think till so many guys.
We had Karan just joined, SKC just joined.
No, we have
Wow,
9
it's a whole bunch
participants.
of people. Harsha just joined.
Oh, hey guys.
Hi Harsha. So basically, so we were waiting for you guys to show up at 5:30. So you guys didn't. So I thought no one would join. So I started with stack first. Like I thought I'd take a question on stack first, and then maybe take Wikipedia crawler next. So are you all like? I don't know. Okay. Only
Yeah,
Harsha and Karan joined. Yeah.
Yeah, I can listen in on Stack as well. Like, yeah.
Yeah, I think Karan also won't. Karan will also be fine with this.
Yes, Ankur, that's
So
fine.
we'll be
then.
going over the stacks question first. Like, so everyone knows, I assume, that what stacks are, right?
Yep.
Right. So I'm not directly going into the stack, what stacks are. So they are first in, last out, ADT, abstract data type, or say data structure. So I'm just trying to solve a very popular question on LeetCode, and is also covered. And there's an IIT course in which algorithms course in which the professor actually uses. So if you go to YouTube, search for NPTEL. So NPTEL. So it's equivalent to how, and it is taken by IIT colleges. So it's similar to Coursera, but NPT is only by IIT and IIMs. So if you search IIT, I think Madras or something, you search for algorithm stacks. This is the question that professor actually explains, and it takes around 1 hour to do that. So I thought, okay, I'll cover this question. So basically, we are covering stacks, and this is the question. LeetCode 739 daily temperatures. You're given a list of the list of temperatures on a particular day. On one day you have 73 Fahrenheit, 74, 75, 71, 69, up to 73, and the output has to be return a list. In the list, return for each day how many days you have to wait till you see a warmer temperature. Is that fine? So 73, the next higher temperature is 74. Immediately you see, so you have to wait 1 day. For 74, it's 75. So 1 day again. 75, you'll have to wait 4 days. So 79, 69, 72, they all there. 76, so it's 4. 71, you have to wait till 76, 2. 69, 1. 72, 1. 76 doesn't have anything, so that's the thing. It will be 0. 73 is 0. And if it is 73 followed by 73, so that would not be a warmer temperature day. It will still be, you won't count it. Is that clear? Is that question clear?
Ankur, I'm still confused. Like, okay, I understand the 75 has a 4 because next day is not a warmer day. The 75 is a warmer temperature. But the 71, it's
Waiting
I
2
see.
days because 69 is lower than 71.
But
72
I thought,
is higher than
okay,
71.
I see. But then here, okay, so if we see lower than the previous one, I see.
So basically, today you have 17.1 Fahrenheit, and based on your temperature app, you're trying to see when is the next warmer day.
I
Right?
see. Okay.
Warmer day. I mean, which is a
More
which is a
warm
day which is
than I see.
temperature than
Okay.
today. So 72 is warmer. So even 70. So if today is 71, tomorrow is 71, it's still not a warmer day than today.
Yes. So 71 is warmer day than 70.
Yes, exactly.
72 is
So
hot.
if you see 73, the last element, it doesn't have any other days, right? After 73, so it is 0.
Yeah, so that's why 0. And 76. But then why not 76? Then 76.
The first
next
warmer
warmer
day,
day.
you're not
The next
returning
warmer
the
day.
warmest day. The next day that is higher than the current day count. You don't need to worry about the hottest day. 72 is higher than 71, so that gets counted first instead of 76.
So the first warmer day. Is it clear? The first warmer day. So you need to return how many days till you see the first warmer day. That's the question. So basically, 73. You check, right? Which find me a day which is greater than 73. So as soon as you see a temperature which is greater than 73, that's one answer. That's the answer, right? For that day. Clear?
Yeah.
What happened? It was Namita, right? Any doubts? Ask. What happened?
No, we understood the question.
Okay. So yeah, Deven. So any ideas like brute force? I mean,
So the brute force would be to go to each index, right? Just loop through the original array, okay? Then have another loop inside that, which goes through all the values after the index. So you start from I, and then you loop from I plus 1 till the end of the array. And you keep a counter. And you initialize that counter to 0 in the first loop. And as you're checking for a higher temperature in the second loop, you increment the counter if you don't find one. Once you find an entry, then you break out of the inner loop. And you put that counter into the output array. So for example, at 73, I would be 0 for the outer loop, and the counter would be 0. And then for the inner loop, you start at index 1. So you check index 1.
So
find
basically
70.
this one, right? So basically for each day I, and then inside for each day j after I, if temperature
Right.
of that day j is greater than the current temperature, you append it to your result and then you break.
Yeah, but you have to keep a counter to keep the number of days that you had to go through.
Now, so basically that will be j minus I plus 1, right?
Yeah.
So j minus I plus 1. Is it plus 1 or I think it's just j minus A? So let's say 73, 75, 2
It's j minus
0
I.
is-
It's going to be
Yeah,
2
j
minus
minus A.
it's just the indexes.
Basically just add j minus A. So is this clear to everyone?
Yeah.
So this is just brute force solution. Basically from the question itself, when I try to explain, that is like clear, right? So like you start from a day, you keep finding. So that is the question. Find out the day which has the next higher temperature. So I think when Namita was asking, when she asked, what about this? What about that? I think by asking, she made it clear what's the brute force solution. Right?
Right.
Okay. Now second.
But for the first one, the space would be what? O of 1. The time would be O of n squared.
Yeah, O of n square, because you have two loops, right?
Yeah.
So this is space. This is your time.
Right.
Is that clear to everyone? I think this is pretty
Yep.
clear. Okay, so now I have a very small screen. I'll do one thing. I'll add in the input again.
So I have a doubt. So if temperature is great in the brute force, if temperature is greater than 0, we will be
Greater than 0 or greater than the ith temperature?
Yeah, we will be adding the number of j minus I, right?
Yes.
Right.
So so how can we differentiate between 1 and 0 there?
Meaning? Say again.
So if the temperature is, so I was just
Oh,
wondering.
the j minus I, you're going to run into a problem if you end that loop. That's the one condition we're forgetting, right? If you go all the way to the end of the array in the j loop, right? You're not going to append to the array. So what you need to do outside of that for loop is
Oh, okay. So you're saying append 0 in case you have not found a solution.
Right.
Yeah, okay.
Was that your question?
Yeah, yes. Yeah, thanks.
So how? Yeah. So how would you do that? I think was it Namita who asked?
Yeah, it was Shiji.
Okay, Shiji. Yeah. So how would you do that? Shiji, how
I
would
would
you?
just go back to having the counter rather than doing j minus I. I'd keep the counter, right?
No. So basically, Shiji, how? Okay, that is one thing. So Shiji, how would you solve it?
Yeah, maybe we have to add some condition outside this loop, right? If it is.
So yeah, I mean, so basically, my idea was that here, right, we'll add a temporary variable called days, and by default, we'll initialize it to days equal to 0.
Right.
And here we'll just update days equal to j minus I, right? And then after the break, we do the append.
Oh, okay, all right.
Right, because if it has never seen, if it has not even gone into the if condition, your days will not update. It'll append 0. If
Right.
it has gone inside the loop, inside the if condition, a days will get updated to j minus I. You break out of it, and at the end you update. Sorry, append. Is that clear, or should I write that code for you?
No, it's clear, but if you're appending 0, well, you're doing it every single time you're under the loop.
Yes. So if I'm at the end as well. So yeah. So Namita, so Shiji, so that was a good like observation. I did not. So basically, when you're at 73, also you start from I. So so basically you start from I. So basically your days, I think it's not go from here. It'll be somewhere here.
It's not going to even hit that loop. That
Before the
for
for
loop,
loop.
the second for loop's not going to even get
Is equal to
executed.
0, and then your append will be after your for condition.
Oh, okay, yeah. All right, that makes sense.
So Namita, was that clear? Sorry, Shiji.
Yes. Yeah.
So basically
Thanks.
to everyone. So that was a good thing. Like, so I'll just write down this question. I'll just write in the answer. So 1 second.
Ankur, can you write a clean brute force?
Yeah, I was writing that only. I was going to write that only. So I'll do it in Python. Okay. Right. So
Yes.
let's. Fine.
Fine. Yeah.
Let's say this is your daily temperatures, and let's say you're given a list T. Let me see if it's being recorded. It's recorded. Wait. So already kept the answer. Okay.
Yeah.
Okay, she is pretty fast. Okay, so let's say this is the result you want to return, right? Let's say it's empty. Now it's empty. So let's say for I, it's a temperature in enumerate T, right? Let's say your days equal to 0 over here. Now for J, other temperature in basically this starts from 1. This starts from I, right? So I'm always confused how that is done. Let's say J equal to I plus 1, while I is less than J. Your current temperature equal to T of J, right? And if current temperature is greater than temp, your day equal to J minus I, you do a break. Here you do a J.
Plus.
Sorry, no, wait.
Yeah, you want to break out of the while loop.
No, this is J is less than I. This is less than length of T. I wrote I is less than J.
Yeah,
So
okay.
basically you start from I. Wait.
Yeah, while J is less than the length of the
Yeah,
array.
Yeah. So basically your J is one temperature higher, 1 day ahead than your today's ith. So J is less than length of T, and this is J plus equal to 1, and here you have to do result dot append days, right? And this is so next time will come. So by default, let's say you are at the last. You start from I. Let's say this is the last index, right? So it will go over here, J plus 1, it will not go into this loop. So result dot append days. So this will append 0. And when it is 76, it won't go into this loop again. So result dot append, and at the end after the for I loop, you return result.
Isn't that J minus I, not J minus 1?
Which one? J minus I.
Days equal, yeah, okay.
J minus I. Sorry.
Yeah. It looks like a 1, that's why.
Yeah. That is why I am the only guy who's using iPad. So you have to, because I have to get used to my handwriting.
Okay.
Yeah. So is that clear? So is that Sue? If you're following, is this the correct one? At what you wrote?
Yes, Ankur, I just did not use another days variable, but I did the same thing.
Let me show that as well. Where's the chat? Here. You guys can see this, what Sue wrote? This chat.
Yeah, yes.
So, Sue, did you also use stack over here?
No, I didn't use stack. I
So what was
just
what is the first and what is the second?
the same thing. First I
Oh,
posted
okay.
it to
Result.
you. Then I thought like after you explained, I thought if there are any Java people, it will help them.
So you also used equal to. Okay, equal to. So basically you're doing plus plus. While
If it reaches the length, then that means it didn't find. So I
the
put
result
it.
of I equal to, if it is j equal to lambda. What is result of I equal to? What is this? Yeah, it is j minus I. J. Oh, okay. So basically 76 will be 0, 73 will be 0 because they reach the end of the loop, end of the
Right.
array.
Yes, yes.
Oh, okay. Is it so same, right? Okay. So is that clear to everyone? I think also Praveen joined. Karan, Arya,
Yes.
everyone?
Yeah.
Okay.
Yep.
Okay. So this is recorded, so you'll be able to see this. So I'll again write the question. 73, 74, 75, 51, 59. And the output is this is 1. This is 1, 4, 2, 1, 1, 0, 0. Okay, so what else can you do? I mean, I know you'll obviously want to try stacks. Okay, use stacks, no stacks. How would you solve this? Anyone wants to try? Sue, Devin, anyone else?
I don't have an idea about stacks. It's just I'm thinking about it, but I can't figure out a way to make it work.
Can you go back to the brute force?
Yeah, this one. You guys can see now. You guys can see the whole screen.
So basically looks like the inner condition can be converted into stack, right?
Which one?
The inner condition that you have, if current temperature is greater than temperature, that is the logic can be converted into stack.
How? I mean, don't worry about the how. So how is it solved? Like,
so like
this is
if
the
you think
question.
about, right, so if you think about it, what are we doing? Like when we are doing brute force, let's take a good example. Let's take this index 0, 1, 2, 2, where we have the answer 4, right?
0.
So,
Which one? This one.
Let me. Can I?
I shared the link. You can just join it, and then you'll be able to draw.
Oh, where is that link? Let me.
Oh wait. Didn't I share it? One second. By the way, on Zoom, it is possible to have a feature in which people can automatically join because I have to keep admitting people. Can I not? Did you get Scribble together? VT?
No, now you're not sharing. So
I'm not. What?
you shut off your screen share.
Okay. No?
Yeah, Ankur, I think if we have a password in the Zoom link, then it doesn't, we don't need to accept every participant.
Yeah, I think for now, yeah.
So
Yeah, maybe I'll try to figure that out maybe later. Yeah. So this is the question. So the brute force was you look at a tree, you look at the current 73, you try to find out from j plus like I plus 1 what is the next higher temperature, right? And and if you get it, you append it to your result, right? So what was the other thing you said? Stacks.
So what I see is here, like you can take a look at the example, right? In the brute force, what are we exactly doing? What are we doing here is, if you look at, we are comparing the temperature in the loop, and we are checking the temperature if it is, I mean, if we find anything bigger than what we have seen, right? And then we are taking the difference. So if you go back to this example, so for example, let's say, how can I write it? Can I write it here?
Yes, try it.
I can.
If you've joined, you can.
Yeah, I joined, but I cannot seem to write it.
Oh, okay. Really?
Maybe I can just annotate on Zoom.
No, wait, let me see if okay, now I think now you should be able to do. I just said allow guest to scribble.
Okay. Oh, sorry, my bad. Okay. So if you see here, right, like I can see that this.
What happened?
PT, we don't hear you anymore.
PT, we can't hear you.
He just got muted. So let's see. Maybe he had an issue with his microphone.
Yeah. So so anyone has any idea? I mean, we'll wait till he comes in. Like if he'll come, he'll explain the idea. Anyone has an idea how to solve this other than that, like the brute force?
This is monotonic stacks, right?
There is no, I mean, forget about monotonic stack or whatever stack. I want you to give me the solution. Like, how would you solve this? I don't even know what monotonic stack is. Single stack? Increasing stack? Is that what it is?
Monotonic stack.
What is it?
So basically you just compare it with the first one with the second one, and then you can see it's like you can use that for different like building comparison and other things.
Yeah, so solve it. So if you I mean, just solve it using whatever more.
Yeah, I just did that long time back. I don't know how to solve it immediately.
No, so take your time. So I mean, think.
But brute force, yes, by using pointers we can actually do that.
This is VT only, right? Who?
Yeah, VT, right? That's
Okay.
Yeah.
So Devin, so you want to try Sue if you want to give a try, Karan. So Shiji, Namita.
I've actually solved this problem already, so maybe I'll let you.
Oh, Karan, okay. Yeah. Then if you solve, then no, then.
Yeah.
Okay. So someone else. Yeah, Devin. So try it out. So basically, you tried 2 pointers, right? So basically, you started with 2 pointers.
Right.
Basically, from the start, right? So that was your first approach, right? From the start. Yep. So basically, your eye starts from back. So basically, you had your. So there are different approaches, right? One is 2 pointers, wherein you. I mean, sliding window also we did the same thing, right? You have I, you have J following I, and then you keep J to the front, and then you keep calling your I to the front. That was sliding window. That was nothing but 2 pointers, right? So right. So
I can give it a try.
Huh?
I can give it a try. I don't know if it will work and if it will fail.
No, don't try. And try to think like what else can you try here? Do whatever.
We can build a stack and traverse from the ending to the beginning. and put the indexes of when is the next like element. Like when I'm at 73, I'll
Mhm.
just push the same index. I'll basically traverse from like n, which is
Okay.
like -1. So I'll push that same index.
You're
And
putting into your index and you're using a hash map also. I mean, you're pushing it to a stack and you're using a
putting
hash
into
map.
I don't actually, with this approach, I don't need a stack.
Mhm.
But I can do it in order of 2, and like in one pass I can just build another array which holds like the next biggest I mean the next biggest number index in that array.
Mhm.
And in another pass I will again start from the beginning, and for that I can see what is the like
So let's say you're at 69.
index of next
What are you going to
increment.
search for? Let's say you're at 69. What are you going to search for?
So I will build the array index in such a way that I will initialize it to of it to be same length as the given array.
Okay.
And when I'm at 73, I will fill like the same index. Like say, can you write the indexes 0, 1, 2, 3, 4, 5, 6, 7?
0.
No, against T.
Oh, 1 second. I think you guys have seen this. Okay. Okay. Here.
So,
0, 1, 2, 3.
no,
Like
it
this,
does
right?
order. No, reverse order. I will
Okay.
start traversing from like last index, but the indexes will remain the same: 0, 1, 2, 3, 4, 5,
Okay.
6, 7.
So basically,
when-
what are you trying to do here? So I mean, first explain what are you trying to do here.
So what I'm trying to do is I will build an integer array of the same size. The index of that integer array holds the index of the next biggest next biggest number.
Okay. So
So
basically,
for
okay,
I
wait,
will,
wait. So basically, what are you doing? So okay, so and for that you do a reverse traversal, is that?
yeah, I'll do a
Okay.
reverse
So let's say you're at 69. Let's say you're at 69.
but
Okay.
and I have to start from the
No, that I understood. So I'm just telling what will happen in between. I mean, wait, whichever.
So when I'm at 73, the index will still be 7, like the same number. And when I'm at 76, like I like my next number is actually like smaller. I mean smaller. So I will continue to hold that same index.
So basically, when you're at 69, what are you holding? So let's say let's say you go back, right? You go from 73 to back. That's what you're saying, right? I mean,
Yeah. When I'm at 69, I'll hold the index of some 72 there.
how will you hold 72? And why not 73 or 76? And
As
let's say here you had let's say 68. How will you know that you need to store, you don't want to store 68?
I see. Yeah, makes sense. That won't work.
So basically what you were saying is, I think there's a different question in which you said that you are going to always store the highest element seen so far.
Yeah, that will not be
Yeah, that will not work.
for all cases, right?
Yes. So Devin, did you get what she was trying to do?
Yeah, I got what she was trying to do.
Okay.
I didn't understand what she exactly trying to do.
So
Indexing.
yeah, so go ahead. Sue, you want to explain?
Yeah, I was trying to like hold the biggest number seen so far index and update that against each of the numbers as long as that number is smaller than that biggest number. But that will not work like when there are.
So basically what she was doing is, let's say I mean, obviously from the front of, so basically this question says that from a particular temperature, you need to find out what is the next higher temperature, right? So it's like you're looking into the future. So using the brute force, it was not giving you an opportunity to see in the future, right? So somehow there's a different approach in which you want to see what already happened, right? So basically what she's saying, let's say you have 2 pointers I and j, right? So let's say I is behind and j is at the front. Let's say you're at 6. Yeah, so basically she wanted to see something in the future, right? So she said I'll go from the back, from the behind. right? And let's say what she wants to build is a list of temperatures or a temperature which is so basically what she was trying to do is, let's say I'm at 69. Somehow by looking the future, can I find out what the next higher temperature is? Did it make sense?
It will actually hold 76 index if I go by that approach, but 72 is also there. How will I know whether to overwrite my highest to be 72 or 76?
Yes. So somehow, yeah. So in that, so she was going correct way, but she couldn't. She wanted to see the future, so she came from behind, and so that approach failed. Like if you go back, she was actually storing some values, and when she read 69, she wanted to find out, okay, what was the last higher temperature. But if you go from back, how would you know that which is the higher temperature in 69? Right, because you have not seen 69 till now.
So as long as they are decreasing, we can add them to a stack. Maybe that way stack can come handy. So I will add.
Yeah, go ahead.
So I will start with 73, add it to the stack. Okay, and 76 is bigger than 73, so I won't add it.
Okay, you won't add it, okay.
And then I will add 72.
Okay.
72. See if we can capture the indices also, or like say against 72 index 6.
6. Okay.
Against 73 like 7.
Okay.
And then after 72 I will add 69.
Okay.
And then I will not add
71. So this is basically a whole stack.
No, I will not add 71.
Yeah, you'll not add 71, you'll not add 75, 74, 73 because they are smaller than 69. Okay, so now what? Now what did that give you?
Yeah, that will not help either. Like for 69, I thought if I have this stack, I thought it will help here to peak the index of 72, but then it is failing for the other.
Okay, so David, did you figure out something?
No, I'm still stuck.
Okay, who else wants to give it a try? Arya, Praveen, Harsha.
So hello.
Yeah, BT, go
on. So what I was saying earlier was, like, if you look at the if you look at the example here, right? Like we have this particular example that I was looking at. We have, let me change.
Maybe
still here?
From the starting and the increasing indexes will help into the stack.
You're still thinking stacks. I don't want you to think in stacks. I want you to first help me visualize what you're doing. Like, help me visualize what you're doing. Okay, so okay. You said stacks, fine.
Right, we want the next biggest number. So we will start from, like, for every number, we just want to look into the future and see what is the next biggest number.
So basically you're saying for 69, I want to see what is the biggest temperature, and it should be 72.
No, I think coming from behind will not work. Coming from behind and storing only when they are decreasing will not work. We have to go from the beginning and store the indexes of those which are only increasing. Like I will add 73, 74, 75, and then 76 to my stack.
Okay. So, and when are you popping out of your stack?
So I will pop, like, and then, yeah, I'll first write it. 73, 74, 75, and 76.
So you added 74. You added what? 75, 76. And what? So basically explain me what are you trying to do here?
I am trying to store the increasing order of the temperatures. How?
Okay,
they
so you added two. I think you in one. Let's say you showed all the. Okay, fine, and you stored them in the stack. Okay, now what?
like we will also have indexes against these, and we have to.
Okay. Let's say VT, were you explaining something? See your left. Hey VT, you want to explain? Okay, so let's say I'll draw the graph. Okay, maybe I'll just draw. Okay, so let's say this is your 73. Okay, we're seeing, right? Let's say this is your 74. Let's say this is your 75, right? So this is 74. Sorry, 73. This is 74, 75. I said this is your 71. Okay, this is your 69. And let's say again, this is your 72. Then you have 76, which is higher. And then you have, let's say you have 73. Right? Is that clear?
Yeah.
Okay, my scale is not proper. Okay. So, okay. Now, what is the answer for 72?
76, 1.
76. 69?
1.
1.
72.
Yeah. And 71?
2.
2.
Yeah.
Right? 75?
4.
76, right? Now, see, so I want to see the graph also.
4.
Right? So what is, okay. Now, and for 74, you have 75. So
1.
73, you have 74, like 1. Right? Okay. Now, okay. Now tell me, let's say between 76 and 73, let's say I had 72, or let's say I had 68. Right? When will 68 be actually useful to me? Is 78 at all 68 at all useful to me? And when will it be?
It's never going to be useful.
When will it be useful?
It will. Okay, 68 will not be useful until, I mean, when you are trying to see the large, because here what you're trying to do here is trying to find the first largest element on your right, correct?
No. So I'm asking you, let's say, okay, let's say I have 68 over here.
Again, how are you doing?
Huh?
I'm good. I have finished my teacher.
So let's say you have 68 over here.
Right. So 68 will not be useful as such.
Yeah, no. So, but let's say I had 66 over here.
Yeah, call me once you're at computer.
Let's say I had 66 over here. Will 68 be useful then? Because now 68 is bigger than 66,
No.
And why?
Because you have 71, right? You want to see the you're not.
Oh, okay. Wait.
Right.
Let's say I had 66 over here.
Still you have 69 next to it.
Yeah. So fine. So basically, what are you doing? So basically, you said correct, right? So basically, whenever you're seeing 66, you don't care about. You only care about the next higher temperature, right? You don't care about all the temperatures that came after.
Screen, what I'm doing for last 1 hour or 1.5 hours.
I think somebody has
So,
to.
Praveen, your mic is
Basically,
open.
what I did was
Yeah.
Okay.
So who was speaking now? Whose mic was open? Harsha or Viti?
Praveen.
Praveen, I think, yeah.
Oh, okay. So basically for
So,
each.
Uncle, sorry to interrupt you, but you mentioned that, okay, when the 68 can be useful. When you are
To
saying.
whom will it be useful?
Huh?
Yeah. So when
68
when
will
it
be
will be useful?
useful if there is a number which is right exactly. That's what you're drawing.
Right
between
before
the
68.
76, yeah,
Right.
between the 76 and 68, that would be number, then 68 would be useful. And that has to be lower than 68.
Right. And okay, now in the previous other examples that I gave, let's say you had 68 between 75 and 71. And obviously, like if you had 67 over here, this 68 won't be useful, right? I mean, because the other temperature which is higher than 67 is 71.
Yeah, for this, that 67, the higher temperature is 71.
Right. Okay. Now now this is 60. Is this 69? To whom will this 69 be useful? Okay. Now I have 69 over here. Let's say I have 69 over here. Right. Let's say I have this is 72 and this is 71. Now my question is now let's say there is some random number here. Let's say, okay, wait. Let's say this is 71. Okay. This is 71. This is 16, 72. Now I've given you only 3 temperatures.
Okay.
Okay. Will 16 now this 79 and 69, don't add anything between 71 and 69. Will 69 ever be useful for any temperature before 71?
No.
No.
I mean, it might be only if there is something lower than. I mean, no, it won't be actually.
Yeah, even if you had 60, even if you have 1, 69 won't be useful because you only 71 will be useful, right?
Yeah.
And if and let's say you had 73. So basically you have no idea what is coming before. Now, but for 73, what will be useful?
71.
Why?
No, none of them will
Not-
be useful.
So 71 is not useful, 69 is not useful, 72 is not useful. So what will be useful?
Nothing is useful.
So,
Zero.
so,
Why?
so what after 72 will be useful?
Oh, 73. Yes, definitely. 71 is not useful. Yeah, that's right.
Right? So what after
Yeah.
72 will be useful? So if you had a number higher than 73, that would be useful, right?
Yeah.
So let's say you had a 74 here.
Then 73 is useful. Otherwise, yeah.
So the intuition here, what you are saying is, we are trying to find the first largest element on my right.
Yeah, that is what the brute force solution also was.
Right.
You are trying to find the first higher temperature.
Right.
Right. But what I'm saying is, will 69 ever be useful?
No.
So no, right? So 69 is just not useful. So why would you even go over 69?
You wouldn't.
Right. So let's say you had 68 here, or let's say you had 68. Right. Will you ever use, so obviously, so not tell me, if it is 68, now what are the useful temperatures here?
73.
73, and then
For 68 it is just 73.
so for this 71, right?
74
Now,
only.
okay, now what about 71 now? So let's say, okay,
Only 76.
No, for 7, sorry, say again.
Only 76.
No,
What is
72.
76?
Is that 76?
This is
No,
71. This is 60.
Oh, that's 71. 72.
Why 72? So what are you saying for 72? What is 72?
For 71, 72 is, sorry, go ahead.
No, I'm saying you had, okay, wait, let me draw it again. Let's say I'll just draw this. This is 68. This is 73. This is 71. This is 69, 72, 74. Is that clear? Now for this 68, okay, is 71 ever be going to be useful? Is 16 ever be going to be useful? Is 72 ever going to be useful? And and not only 68, but for any term that comes before 68, will 71, 69, 72 will ever be useful, and why not?
So
It's not going to
73
be useful because 73 is higher than any of those values.
Okay, say again, Devin, like if people miss that.
Okay, so 73 is higher than all of those values, right? So those
70
values are never going to be useful once you hit 73.
Is that clear to everyone what he said?
Yeah, because that's the first largest element on my right.
Say again.
That's the first largest element on my right.
First largest. What about 74?
74
That's
is bigger
not the
than
first.
73.
That's not the
but-
first largest. That is when I'm walking from left to right. What is the first largest I see? That's 73. 74 is in the future. I don't care about that, right? I just care about what is the first largest element.
No, that is fine. That I understood. So for 68, you need the first highest temperature.
Yeah.
What I'm asking you for, okay, that is the one. All the temperature, okay, you have no idea what comes before 68. Let's say you have no idea what number is coming before 68, right? Let's say you get 65, you get 85 or whatever. Let's say two things. Let's say you get 85, or let's say you get 58.
Right.
Will 71, 69, 72 ever matter?
No.
Will 68 matter?
Yes.
Okay. Now, okay, for 258. Okay. Now let's say you get 85 now. You get 85.
Right.
Or let's say you get you get what do I say? Okay, for 50, you said for 58 you have 68 that matters. What else? 73 and 74. The rest of the terms are not useful, right? Is that correct? You guys,
Right.
I think you guys lost. Okay. So what I'm saying is, for any temperature that comes before 58, let's say 45. Okay. What are the useful temperatures? Okay, that's not even good question. Okay. Now you have 74, you have 73, you have 72, 69, 71. You have 68, and you had, let's say, 40, 58 and 45. My question is, you guys said that 71, 69 and 72 are never going to be useful, right? What about 58? Okay, you get, okay, let's say, what about 68 itself? Will that be useful? That is useful, right, for 58? Because 68 is the next higher temperature than 58. And for 58 matters to 45. But that is the next higher temperature than 58. Right?
Yeah.
Okay.
So Ankur, are you suggesting we move from the end towards the beginning? And I think what you're saying is if my left is lesser than me, like 68, for 68, 58 is lesser, then so far only 68 is important. We discard everything before, whatever we have seen, walking from 74 to 73.
Wait, okay. What if you get 71 again? Who's going to be useful? 1. Let's say before 58, before 58, you had 71. Now what?
Yeah. So before 58, if I had 71, then 71 might be useful for somebody that is before.
No, but what is the answer for 71? Who is the higher temperature than 71? 73, right?
71, 73, yes. So we want to maintain the highest that we have, I think, I don't know, something that we've seen so far.
Okay, now let's start from the beginning. Okay, you had 74, fine. You had 72, you had, so okay, 74. Who is 74 useful for? Anything that is less than 74?
Less than 74, yeah. Everything that's less than 74, and which is
right. Okay,
yeah.
Now as soon as I see 76, let's say between 72 and 74, I had 76.
Yeah, now 74 is useless for anybody.
Is that right, everyone?
Yeah.
Yeah.
Okay, so first I had 74. Now I saw 76. So anything which is
anything less than that after.
Yeah, like 74 now will be of no use for anything that is on the left of 76.
Okay, let's say you had
Right.
78 over here.
Because we've hit a peak.
Let's say you had 78 at the end.
Mhm.
Okay. Now let's say you start from 78. You had 78. Okay, this is useful, so you add it. What about 74?
Yeah, we'll
You could
still
add it.
Add it.
Right?
Yeah.
Okay, you 74 is useful. Now you add 76.
You get rid of 74 because it's higher than. When you add 76, you get rid of 74.
So say again.
So if the number you're adding is greater than the number on top of the stack, you pop it.
Oh, okay. You had 76. Fine. So you pop this out. Okay, you remove it. It's 76. Okay. Now if it is 75.
Add it.
That's fine. I think you added.
Add it. Okay. Now let's say you get 77. Now what?
You would pop 75. You would pop 76.
So now you have 77 and 78.
Right.
So why? Because 70 and 77 and 78 can be useful to some other temperature, right? There might be a temperature which is now let's say out of 77 you get 70. Let's say you get 84. Now what?
Everything would be popped. You would pop 77 and 78.
Yeah.
So basically now, now so any temperature that you get below say 84, if you get 36, your answer will be 84, right? So anything which comes before 36 now, anything, the temperature will be 84 until and unless it is less than 84. 84 is going to be important, right? But if you get 85, now 84 is no more important, right? Okay. So what are you storing in your stack? I mean, someone build it. Someone say it into words.
So it seems like we are like if there is a mountains, we are storing all the peaks. Is that right?
Someone say, is it right? Is it wrong? Someone put it into words. Like whatever I said till now, just repeat it. Whatever I showed you right now. So basically, this is what was happening. So let's say this is 78. This is 76. So you said 76 is useful. Then you added 75 and you kept 76 because 76 was useful. Now what did you get? You got 84. Let's say you got 77. Okay, you got 77. Now you're saying 75 and 76 is not useful, right? So 77 and 78. Okay. Now let's say you get 73. You put 73 here, right? Is that right? Now let's say you get 79. Now you're saying that none of these are useful, right? Okay.
Yeah.
Is that correct, everyone? Now see here, what is happening? You were storing 78, you stored 76, you stored 75, and as soon as you found a number which is greater than 75, you removed 75 and 76, right? And you didn't remove, you kept 77. So what is the relation between 77 and 78? 77 is less than 78. Okay. 73. Huh?
Decreasing order. I think we're preserving the decreasing order.
Yeah, and 73. Yeah, so basically 73. You got 73. Okay, 73 is less than 77.
Yes.
You put it. You're using it because it might be useful to a 72. But now, as soon as you get 79, now none of this are useful. So you remove all of them. And also, if you see, so now let's say this is your graph. Okay, let's say you get a temperature over here. You get a dip. You get a top. You get a dip. You get a top. Whenever you get one more increase. Okay. So what you're doing is you're storing this one. You're storing this one. You're not using this. You're storing this. You're not storing this. You're storing this. Right? If you see, so basically that is what you're storing only the increasing temperatures, and anything which is between them, you're not storing them. Is that right?
Yeah.
Sue, did you get?
Yes, Ankur.
Everyone? Devin, I think you got it.
Yes.
Yes.
Right. So basically, okay. Now let's say we go to the example again. Okay. Now let's say you had 73, 74, 75, 71, 69, 72. I mean, this is a question that actually, okay, wait. And the answer is 1, 1, 4, 2, 1, 1, 0, and 0. I mean, we tried brute force, it didn't work, right? And we couldn't even think of any other solution, like just from your basics, right? So we started thinking, okay, we started building up all of these intuitions. I mean, that intuition is absolutely necessary. If you don't do that, you cannot get to understanding that what we have to do, right? So basically, we go from back. You store 73. Okay, now you get 76. You remove 73. You put only 76, right? Now you get 72. You put 72. You put 69. Okay, so here this is your stack, whatever. So you put 73. You get a number 76. You remove this. You make it 76. You put 72. You put 69. Now what? What will happen when you add 71?
You get rid of 69.
And okay, you remove 69 and you add 71. So you added 71. Okay, and then after 71, what happens? You get 75. What do you do? You convert this into 76 and 75. Okay. Okay. Now when you wait. Yeah. So basically, you had 60. Wait, what did you had before? You had, what did you had before? You had 71 and 72. So is that clear what we're doing in this? I mean, the use of stack over here?
No, Ankur, actually, why do we have to go from back and do it and add it to a stack?
Because while building the intuition, that is what I'm just telling you that, the intuition right now, basically for 75, okay, is your question that how are you getting the index?
No, not yet. No, I didn't even go there. So if in the stack, if we are only storing the increasing order, right? How do we access, like, you see, can you scroll little up? Yeah, where you had that graph where we are storing only the peaks and ignoring the between ones.
This one?
No, even below.
This or this? Or this?
Yeah, this one.
Okay.
So if we are storing only this, see if there is something in between, we will miss out on that, right?
When will you miss that out?
Say for the intermediate, the second vertical line, if there is.
This one. If there is?
Okay, if there is, okay, something less that would have been captured. Yeah, my bad. Yeah, clear, Ankur.
So basically we are over here. If let's say this number didn't get added, this would still be in the stack. So basically this is still there in the stack. This one, this, and this. Right? We have not seen this till now. As soon as we get this one, now this won't be useful. Then you pop it out. Then this one is not going to be useful. Only this one is going to be useful. Is that clear? Not clear.
Yeah.
So
yeah, it got clear. I see why we are traversing from the back, because we want to go because our graph is a linear. A graph is a linear, so we are coming downwards. So we maximum always gonna stay in a stack bottom.
Yes. So this is what happened. Okay. So this is what I draw the graph. You get this one in your stack. You have this. Till now, this is also useful. This is useful to an element which is less than this number. Is that fine?
Right.
But if you get a number which is higher, then this is not useful. to whom will it be useful? Every answer which is every temperature which is coming before this one will either use this one or use a temperature which is either this or this or this.
Okay.
Right?
Mhm.
Right? It will never use this. It will never use this. It will use this or this or this or this one.
Right.
Right? Now you understand?
Yeah.
Everyone clear? Like why we are going from behind is like we couldn't figure out how to do it from the front. So we had to go back. It's like so these are the frameworks that you learn. Okay, I'm going to try this approach, that approach. Okay, let's go behind, let's go to the back and see what is happening. Because using arrays you can see in the future. And you can even see in the back. Right? Okay. One of the approaches that so is this point clear to everyone? Till now what we did?
Yep.
Right? Okay. Now let's say I'm digressing a bit. So the first brute force solution that Deven gave was a 2-pointer solution which was nothing but O of n square, right? So if you know the question 2 sum, brute force you start. Do you know that? Everyone knows what the 2 sum question is? Find out 2 numbers in the array which sum to a particular number. Let's say k is a number. You know, everyone knows this solution, this question. Deven, have you seen this?
Yes. Yeah.
So okay. So should I go into this question first, or should I continue the stack question? You guys say.
Stack
Continue the stack
Yeah,
question.
continue the stack. Yeah.
Okay. So I just say one line then. So this 2 sum, right? So what are the ways that you do? So you ask to the interviewer, is it? Okay, the interviewer says it's not sorted. So what do? You have only one way, right? You have I and you have j. You both start from the front. You use a hash map. You store the variables which you have seen so far, and your j is moving, and you see is there the element that has come before the j, which is present in the hash map. So that's one of your approach, right? Another approach is okay. The interviewer said it's sorted. You start from I at the front and you start j from the the end, and then you get both of them here. So this will be the another 2 pointers technique. Now here that won't help, right? Because in the stack solution, this question, let's say you're at 69. Let's say you're thinking opposite, right? Okay, for 72, okay, it won't work here. So okay, let's not do this. Now that the other approach that comes to mind, okay, let's go from the back. So it's like these are things that you actually think that that would how even I would think in the question. It's not working from the start. Even that 2-pointer solution didn't work, hash map. I'll start at the end. So that's the first intuition, and then you start doing all these intuitions which we did here over the graph. Okay, someone might take 5 minutes, 10 minutes, someone might take 1 hour. Okay, but this is a very popular question, and you'll get many questions like this only. And you have to understand that what is happening here. Why stacks are beautiful over here. Okay. Okay. Now, Sue, did you get everything till now in stacks?
Yes, Ankur.
Okay. So where were we here? So we were into the 71, 72, 76 stack, right? And now let's say we get 70. So you had 71. Okay. Now you got 75. Now what? You'll remove 71 and 72. You will make it 75, 76. You'll add 74, and then you'll add 73. Is it clear? 76, 75, 74, 73. So the first intuition that we are maintaining a stack which is of decreasing order. Is it correct? Is it right to everyone?
Yep.
Okay. Now my question is, okay, I've done the stack. How is it going to help me? How is it solving my answer? I need this answer. Help me.
You would store the indexes rather than the values. In the stack, you would store the indexes, and then you look up the value from the original array, and pop the indexes that are lower than the current value. And then, as you're walking backward, the difference between your current index, the difference between the index at the top of the stack and your current index, will give you how many data away you are.
Man, okay. Has everyone understood this solution that Deven just say, or what his idea, what he said just now? I need a yes from everyone. Even if a no,
Yes.
then do spell me.
Yeah.
I don't think Harsha, Sue, Arya, Namita, Praveen. Who else is there? VT, did he still there? SKC? Who?
Yes.
SKC? Is it
Yes,
CG?
one moment. Yes.
VT, did you get this? What he just said?
Yes.
Okay, now I'm going to start. I'm going to ask someone to explain the solution again. Okay, I'll ask Sue. Sue?
Yeah, Ankur.
Yeah, explain what Deven just said.
So he said we will store the indices of these numbers that we have written, right?
Mhm.
So for like we will build this stack and like then we'll again iterate from the beginning and we will peek into the stack on what is the next like increased value index and we'll subtract.
Wait. What did you say just now? Wait, say again. Why are we going from the start? Wait. What did we do here?
So we built the stack.
But at the end, we only had this one, right? Okay. Okay. Now, okay. We have only 73, 74, 75, 76 in this stack. And you're saying these are indexes of 73,
We should
74?
not go from the beginning, but okay, got it. So we will, before popping, we will like fill the result at that index and then pop. Whenever we, and we will not go from the beginning again. At the time of
We will go
popping
from the end.
itself- yeah, at the time of popping itself, we will build the result index, result array.
Okay. I'll just say this one. So all we are doing in the stack is instead of adding 76 or instead of adding 73, we first add 7, which is the index of 73. Right? Now, array of, you can easily get what array of 7 is, right? Now, let's say what you get here, 76. Right? Now 76 is greater than array of 7. Right? So you remove 7, you add 6 over here. Right? I mean, you're going from back. Now what do you get?
Yeah, when you what I'm saying is when you pop itself, like then at the array of 7 we will fill the value.
Yeah. So basically, when you popped, when you came here 76, you look into the stack, you look at the index of whatever is there in the front, and you keep popping out till you find a number which is greater than 76. Now you find a number which is greater than 77, which is the index. Let's say 7. Now, if this is 5, that means you know that 76 is here. It's 7. So you just do 7 minus 5, and this is your answer, and you put it into your result. Is that clear? What we just did now?
Can you explain again?
You want to, okay. Let's say this is your stack, right? Let's say this is okay. Just say this is 7. Okay. This is 5. This is 3, and these are the indices.
Okay.
Right? Let's say this is 72. This is 73. This is 76. Right? Now let's say we are at index 2. Right? And we got a 78. Or let's say we got a 75. Correct?
Okay.
Okay. So we got the number 75. We look into the stack. We find out the element at index 3. We get 72. We pop it out. We get 73. We pop it out. We get 76. We know it is we know the index of 70. This right 7. We know the index, right?
Yeah.
So what is, so we are at 70, we are at 76, which is index 7, and we were at index 2. So that means the higher element than 75 is stored at index 7. So 7 minus 2 is 5. So 5. So the next higher temperature than 75 is stored 5 steps ahead, right?
Okay.
So your result gets stored. So your result of 2 equal to 5, right? 5 days.
But by popping these intermediate values, right, we need them for calculating like between 2 and these like index.
Yeah, valid question. Say.
So like we said, like when we are at 72. Or what is like we like when we are at 75, we saw that 72 is less, 73 is less, so we popped out and we saw 76th index, which is 7, and we subtracted this index minus that index. But then we lost 72 and 73, right? They might.
Do you need 72, 73 ever after you push 75? Okay, you got 76, which is your stack minus 1. a stack 0, right? You didn't pop it out. You just got 76, right? You do a peek, and then what you did? You added 76. You added 75. I mean, you added. This is your 7 inches. This is your 2. This is 75, right? This is your 76. Why do you ever need 72 and 73 again?
Okay.
Do you ever need 72 and 73 again? No, right? That was what we went, right?
Okay.
You see 76. You store 72 73 because you want decreasing order. You suddenly see a number which is greater than 75. You remove these two. Now your stack has only 75 and 76. Not clear? Should I explain again? What happened?
Ankur, can you take the entire question and add the index and then start from there, adding to the stack and removing?
Okay, one sec. What do you return? Okay, let's say we'll find out the answer and then we'll match it with your answer. Okay, this is 0, 1, 2, 3, 4, 5, 6, 7, and you need to create a result. So this is your result. Okay.
Yeah.
Fine. I mean by default, initially it will be 0 only, right? The end one. Okay. Okay, now let's say now this is 7, right? 73. Now initially your stack will be what? Okay, wait.
Your stack will be 73. Or 7. Your stack will be 7.
So your stack will be 7, right?
Right.
Okay, yeah.
Okay.
That's right.
And
okay. Your I mean your I equal to 7. You look into the stack, it is empty. Since it is empty, there is no number that is less. There is no warmer day. You append 0. That's fine. This is the answer. So wait. So you are at I equal to 7, right? Initially your stack is empty. Correct. So that means there are no elements. Though there are no days which are warmer than I equal to 7. So you add 0. Okay, and then you add 73. Oh, sorry, you add 7. Into the stack, we are only putting indexes, but in case if I say the temperature, you'll understand what I'm saying. Okay. Okay. Now when I'm at I equal to 6, I check into my stack. I have 7. I check the temperature. It is 73. I pop it out. Right. I keep popping out till the temperature on the stack dot peak is less than or equal to the temperature I'm currently at. Till that time I keep popping it out, also making sure stack is never goes empty, right? So 73 goes, everything is done, right? Now my stack is empty. That means I'm not going to see a temperature which is higher than 76. I add 76, I add 0. I added 0 because I kept popping out, trying to find a temperature higher. I couldn't find. That means there is no temperature higher. So I put 0. Is it clear?
Yeah.
And,
yes.
Okay. And
Yes.
you guys understand, right? This is, I wrote 76, but this is actually 6. I'm adding the index.
So Ankur, to understand what you're saying, like you walk through array over and over just to get an
you're
answer.
walking through it from the back.
I'm walking it from the back.
Right, but you're walking it from the back all the way to index 0, from 6 to 0, then 5 to 0.
No.
Is that what you're doing?
No, you're
I'm
only
storing
walking
it only
through
once.
it
I'm going.
one by one.
Right now. I'm only at 7.
Okay.
Okay. I'm building up my solution as I'm going from front till the back. I'm not doing multiple times. I'm doing only one pass. So only one pass. Okay. I'm at 7. I was at 7. I wrote 0 here. I'm at 76. Basically, I wrote 0 here. Okay. Now tell me, what will I do for 72?
72, you see that 76 is greater than I am. right? So you
But
you just calculate the difference between 6 and 5, which is
1.
1.
So I'll add 7 over here. And into my stack, I'll have what?
And then you add
6
72 to the
and
stack.
5.
Yeah.
Is that right, everyone?
Yeah.
GG?
Yep.
Yes.
Okay. Now I'm at I equal to 4. Now tell me what?
You
I'm
do the
at
same
I
thing that happened at
69.
72.
Okay. Easy. Okay. So you had 6, you had 5,
5,
you had
yep.
you put 4,
4.
and you add 1 over here. Okay.
Right.
Now I'm at I equal to 3. What is the number? 71. Okay. Now what?
Because 60, I don't know what the number is, 64 or whatever.
69.
69 is less than I am. I don't care about it anymore.
So
Right.
those stack dot peak is less than
Right.
or equal to temperature. Even if this was 71, I don't care. I have to remove it. Till this is till so huh?
No, we have to remove just 69, right?
Yeah, we need
Only
to remove.
yes, only remove 69. So that is all.
Right.
While so basically
While stack dot peak.
no, while stack, so basically your stack is not empty and stack dot peak is less than or equal to temperature. I do stack dot pop of 0. Basically just an array, I'm popping it from the start. Okay.
Yeah.
Clear? Okay. Now I got 71. Now what will my what will be the values in my stack? I have 6. I have 5.
You have 3
4.
or 4.
4 is popped out.
4 popped out, so you have 3.
So just 3.
Okay. And till where did I go? Till 5, right? So basically I am 71. I popped out 69. I read 72. I got it as 5. Right?
Yeah.
It's 2.
Okay. So what is it? 2. Okay. Now I get I equal to 2. I equal to 2 is 75. Okay. Now what? I get 75. This is my stack. Obviously 6. This is 76. This is what? 72. This is 71. Right?
Yeah.
Now we're at 75.
Wait. I have 72 also, right? I have 72 and then 71. Yeah. Now I get a 75. Now what? So basically
Right,
6 will, so I'll keep popping out. 3 will go, 5 will go. I'll eventually reach 6. I'll add 2 over here. And into my result, what I'll add? 2 minus 6, which is 4. Right? So my 4 will come over here. Okay. Now let's go for 74 now. Oh, okay. I mean, I equal to 1. We have 74. 74 is greater, like less than 75. We just append. Basically, we keep checking. It is 2. 74 is 1. So this will be 1. Right?
Mm-hmm.
Similarly, for this 73, it will be 1. Okay. Now let's see what the solution is. Okay. So your output, I mean, I'm checking lead code. So it's 11421100. So that's what the result is. So did you guys understand what we did here? Like how stack was useful?
Yeah.
So basically we went from the start, from the end till the back, and we were storing all the results we saw till now in the descending order. So, and we stored that temporary result. So basically we needed a data structure where we could store all the decreasing warmer temperatures, right? And as soon as we found a temperature, we got a new temperature, we just went into that list and tried to find which is the next higher. That's it. So instead of navigating from the start, we went to the back, and let's say when you're at 60. So you started from the front, from the brute force, nothing happened. Now you started from the back, you went at 69, you tried to find out, okay, what is the temperature higher than 69? Okay, 72. Then 76 is 1. But then you I mean, intuition, okay, 71 won't be useful. Let's remove 71. So that is something you can see. I mean, that is something that is what problem solving is all about. You have to keep writing.
I think you can still do it from the beginning. I mean, the same way. Only thing the condition will change the way you are handling in a stack.
I mean, you mean you go from here and your index, you're using your index.
Yeah,
to
you
build
can
the stack.
you can still go from 0th index to 7th index, and you can still get the right answer. Only thing is your condition will change. I mean, what are you going to pop out from the stack?
Okay, well, we'll go into that. But is this answer clear to everyone? Like what we did? Do you guys want me to write the code for this? Okay. Yeah.
No.
So this is VT, right? Yeah. So what will you do if you start from 0?
First, I will say, otherwise I'll again have some audio issues if I start writing it down. So if you look at, if you walk from the beginning to the end, let's say you put 73 in index 0, right? 73 in stack. We will put index, but let's talk about the temperature. Let's say you put 73 in the stack, right? And with the same intuition, what are you going to do with 73? Nothing. There is just one temperature as of now. Next, you see 74, right? So when you see 74, what is that going to do? So what is that going to do is it is going to remove all the temperatures less than that, right? But at this point of time, we only have one, correct? So it will pop 73 out. It will pop 73 out. The difference is 1, and the answer will be 1 for that. And it will put 74 inside, correct? In the stack. Now, you go to the next number and you see 75. 75 is going to push out 74, and the difference between that is, again, 1. So now you have 75 in stack. 71 will come. It cannot move 75 out, right?
Okay,
so
okay.
So it's the same logic. It's the same logic. So you have 75.
Okay, now
you
let's
have
say
71. Right.
Okay.
And then comes along 69. It will be
no,
there.
but where is the result? Wait, you added 74. You added 1. Okay, but
Right.
so what did you add for? Wait, let's say you had 76 over here. Where did I go?
Let's see. Let's see.
Okay, let's say you had 76 at the beginning. Then what did you do?
Wait,
Not
let me.
73, right, in the beginning.
The
beginning it was 73.
Let's say you have this, right? You have 73, 74, 75, 71, 69, 72, 76, and 73. Let me write the index here. 0, 1, 2, 3, 4, 5, 6, 7, correct?
Yeah.
And let's say you have a stack here, correct? So what you're going to do for, and let's say this is your result array, right? This is your result array, and let me just write the index 0, 1, 2, 3, 4, 5, 6, 7. Okay. So sorry about the background noise again. So basically what you're doing is you'll put 0 here, which is nothing but 73, correct? And right now then your iteration goes here, correct? So
so before that, can you explain what you're trying to do? I mean, this is your stack. I mean, what are you trying to do? Let's say you're at 71.
Right.
And you're looking for a temperature which is less than 70.
Okay. Oh, okay. So what I'm trying to do is like, now if you think about whenever you encounter any temperature, right? What is that temperature going to do for you? I mean, so one is whether it can not do anything, like with whatever, I mean, okay. So the logic here is.
So wait 1 second. So is this right that when I said that you're storing this, instead of going backwards, you're going like this and you're storing big ones? Is that right? Okay, now go ahead. Sorry.
So basically, whenever you see any temperature, right, and you're using stack. So what is going to pop the temperatures out of the stack? If you see anything higher than what is currently present in the stack is what is that going, and that is what you're going to pop out, correct? And that is what you're going to use to see the difference between the indexes.
Yeah. So basically, I mean, so basically, if you have 71, you're going to pop out.
So let's say
everything which is less than 71.
Right. So for this example, let's say you reached at 7, assume there is nothing on the left, right? There's nothing on the left hand side. Like what I'm saying is, assume that there is nothing on from here. You don't have anything, correct? Like from point index 2 onwards. So let's say the first element that you see is 71, correct? When you put 71 in stack, who is going to kick 71 out of the stack?
75.
Any number bigger than 71, right?
Yes.
Any number bigger than 71. So that's the entire logic.
Okay. You cook 71 out. What did you
Much-
what do you add the result?
This is the logic.
What do you add in the result?
So let me walk through this, right? The current one that we are looking at. So you have 73, you go to 74. When you go to 74, what you look at is, you look into stack, correct? And you see 73. I mean, is 74 going to kick 73 out of stack? Yes, because it's lesser than that. And I now know the answer for index 0, correct? Because that's the first largest element on my right. So that's all I'm doing, and that's all I'm doing. So when I kick 73 out, I'll take a difference between what I'm going to put next. So currently I'm at index 1 and I have index 0. So I'll put 1. Where did it go? I'm going to put 1 as an answer, correct?
Yes.
And then wait, do you have a eraser here?
Yes, it is bomb.
Bomb is an eraser? Okay.
Yes.
Okay. So you're going to remove this, you're going to remove this, correct? And then you're going to put 1. Correct?
Yes.
And now you go to the next element, correct? Now you go to the next element. So when you're looking at this temperature 75, what is it that you're going to do? You look at the stack. If there's anything lower than me, right? You're going to kick that out, and you know that you have the answer because you are the bigger one than the one which is already there in the stack.
Yes, right.
So as the first largest element. So what you'll do, you'll just take the difference between 2 and 1, which is answer is 1. So you'll write there. You'll pop this guy out, right? And you'll pop this one out.
You'll add 2.
Right. You'll add 2. You'll add index 2, and you are at you know at the temperature is 75, and then your index is
71.
Here.
Yes.
71. Correct. Now 71 is in no way going to. It's going to look at the stack peak, top of the stack. It is not the next largest element, right? For that. Next largest element on the right. It is not the next largest element on the right. So what is it going to do? It is not going to do anything because he will just put himself back in the stack in the hope that he can find somebody larger than himself. Correct? So I'll put 3 here. 71.
Wait. You put 3. You put 2. You put 3.
Yeah.
Okay.
Yeah. So whenever I find anything smaller, I don't need that now because I need to pop that out, right?
Wait. First you had 75. Then you had 71. Which one did you didn't pop out 71?
I did. I inserted 71 now.
You didn't pop out anything.
I popped out 73 and 74. That's how I have
on
an
what
answer.
basis? On what basis? So basically you had
73.
Okay.
So 73 got popped out by 74 because we have an answer, right? Because that's the next largest element than what is there on the stack. 74 got popped out by 75 because that's the first largest element on its right, correct? So that's how we have an answer.
Okay.
Now 75 is inside the stack, and 71 cannot move 75 out because that's not the next largest element, correct? So 71 went inside, and same goes with like we go to the next element.
Wait, and your answer?
Yeah, I don't have an answer yet. Wait. So I'll go to the next element, right? Next is I'm here, correct? 69. Is 69 greater than what is there in the top of the stack? 71, which is not correct.
4.
You know what? I'll just put myself back in the stack and hope that some next bigger guy will come and it will kick me out. Correct? So now I'll go to the next guy.
Now you pop out 1671.
So I'll go to 5, right? Yeah, right, exactly. So I look at this. So my index is 5. I look at the top of the stack, 4. And that is 69. Of course, I'm going to pop myself out, right? So my index is 4, correct? So what I'm going to do? At the warm index. So this is the index, right? Let me.
How do
okay.
what?
So this is the index. Okay, this is the index, right? Correct?
Okay.
I'll use this index, okay? Because I'm finding the answer for this guy.
72.
Yeah, no. Right now I'm at 72, correct?
Yeah, so 5.
But what I'm looking at the top of the stack. Top of the stack index is 4.
Yes.
And I'm finding the answer for 4. I'm finding the answer for
yes, it's
4.
for 4. Yes, right.
So for 4, the answer is, 72 is bigger than me. And of course, I'll put 1 here at 4, correct? And I'll pop it out.
Pop 69 out.
I'll pop 69 out, correct? Now I'll look at 3, 71, correct?
We'll pop it out.
I'll pop it out, right? 73, I'll pop it out. I'll see the difference. 5 minus 3 is 2. And for what I'm doing this
71.
I'm doing for 71, right? So at
About
index
71,
3, right. Index 3, 71. And I'll take the difference. I'll put 2 there as an answer. Difference between 5th index and the 3rd index, correct?
Wait. Yes.
So you are at, right? So now, so I'll pop that one out too, because now I have an answer for that, correct?
Wait.
So I'll pop this one. Okay, let me go back.
Wait, you have the
Let me go. Yeah.
Okay.
Is this correct? This is where we were, right? So now we are at 5. We are at 72, right? 72, and top of the stack is 69, right? So of course I can easily pop that out because I'm the next largest guy. And then I'll go. So 4 will be gone, correct? 4 will be gone, and the difference between their index is 1, correct? So this is gone. Now my top of the stack is 3. Am I the next largest element? So is index 5 the next largest element for temperature at index 3? Yes, correct?
Yes, I mean, you remove 71, you put 72.
I didn't put anything yet. I'm just comparing. I will keep on removing elements which are smaller than my current index. And only when I couldn't find anything smaller than me, I will insert myself in the hope that somebody else will kick me out, because I'm trying to find the next largest element on my right-hand side.
So basically next time you'll get 76, you'll go back, you'll find 72. And
I'll remove all the way till 75.
Okay, and 75 is what? Is the smaller number than 76, the highest smaller number than 76. I mean, basically you take, so basically you took 72, the next, the lowest temperature, I mean the last number that you removed.
Right.
71. So
exactly.
71 is what the answer you made, right?
So with 72, I got an answer for 69 as well as 71. What did 72 do to us? What did 72 do to us is, if 72 is the next largest element, then it is going to remove all the smaller element before it. And the difference between their index is the next warmer day. So let's say now,
but VT, but I think we were going with the increasing solution. I think if people are still not like, I mean, I know, I mean, I can see, it's working.
Okay. I tried 2 times to tell you my intuition, but because of this iPad and Zoom together it couldn't work. Somehow when I moved to Scribble board, my audio was cut off. So now I had to use 2 devices to talk now.
Okay. So guys, did you guys understand the use of stacks over here? Why we are using stacks?
Yeah, but the question I
Good.
have is, how do you get to that?
Wait, one second. Devin, yeah, what is the question?
So I understand it now, right? But let's say I'm giving this an interview, right? How do I figure this out within 20 minutes?
Yeah.
You try this question many times. You figure out what is happening. So basically, when you looked at 73, 74, 75, right? So this thing,
right?
This is what you start from the beginning. It doesn't work. When I tried the approach, I started from the beginning. It didn't work. I looked at the end. Okay, then I figured, okay, there's some order. I mean, this question you cannot solve unless you have seen this question before.
Okay.
You cannot.
I'll tell you guys one thing. So as a practice, what one can do is, like, when you're given an array, you can build an array like the first largest element on the right, first largest element on the left, first smallest element on the right, first smallest element on the left, and use stack to build that. In this problem, what we are doing is we are trying to find first largest element on the right, but there are other problems that you will see, like a skyscraper problem or something else, right? Or where you have a building and then you are pouring a water, and it's going to between the 2 poles, how much water it can accumulate. I don't know if you're aware of this question, but it's one of the LeetCode questions. So there, what you have to do is, like, you have to find, when at any given point of time, you need to find my first largest element on my left and first largest element on my right. And that is what is going to contain all the water above me. So this is a framework, I would say. It's a standard framework question. If you can calculate this, if you know how to do it, to come up with the first largest left, first largest right, first smallest left, first smallest right, there are a bunch of problems that you can solve with that.
Maybe VT, you can take this session maybe tomorrow to choose that pattern. I mean, if you're saying if that pattern actually helps, you can do a lot of questions. I mean, use that pattern, then you can explain it tomorrow.
I can explain it. If I'm not able to join, I will send it on Slack.
Yeah, but not now because I want, like, guys to understand this one first, and then maybe use your pattern. You send it by Slack. We can check it. Then maybe we'll understand this one as well. Like, to build, because obviously when I don't have an answer, like whatever Devan asked, right? How will I solve it in 20 minutes? You cannot solve this in 20 minutes until you have some magic wand or something.
You cannot
look at the question. Because the thing is, most of the questions on Stack are going to be using this. So I think someone said about monotonic stack, right? Was it Karan? I think he left. I think that is
I haven't heard that term before.
Yeah, so I think monotonic means either decreasing stack or increasing stack. That is monotonic stack. So if you know what that pattern is, then you can to tease that pattern is why people tease this question. And if you have like seen 3 or 4 questions on that, you can immediately see, okay, this is nothing but the traffic. This is nothing but the daily temperature question. Then immediately you can solve it. This is what we do with other patterns also, right? Like try sliding window. You learn one pattern and then you can figure out how to use that again and again.
See, I want to add one point, right? These kind of patterns, everything, instead of using a number, you use the index. That's the only difference. Here, basically instead of whatever the index is there, right? You use that index to store in the stack, and then you are comparing. That's it.
We did that only, no? We stored the index only.
No, you can start from the beginning actually. I'll put the code in the Zoom just to see yourself.
Put it into Slack, that's our group. Yeah, put it into Zoom. Maybe everyone.
Zoom. Yeah, in the Zoom, I put it there. Just take a look and then you get idea what this is the pattern. This I did in 2018. If you see in Java, there is a peak.
This is what
peak method is there.
Yes, results.
Yeah, Vijay, that's what I was explaining.
Yeah, I think VT also said the same thing.
Yeah, basically the peak,
from
you
start.
know, you don't consider the first number, you consider the next number because the 0 is index. That's what it does.
But no, but the intuition, I mean, but the intuition for that was the intuition was that all the temperatures are decreasing. And so once you see that intuition that all the numbers are decreasing, then you figure out how to code it. Either do it from start or from the front. I mean, you figure out, okay, we are going to kick some questions out, like some temperatures out. So then that's the second thing, like you code it up. But first was the intuition, okay, all the temperatures are decreasing.
Yeah, definitely. This
increasing.
is one of the strategy. Yeah, good strategy actually. This is a popular for a Bloomberg actually. They ask a lot of stack questions.
Yes.
It might be number, it might be strings or something like that.
Yes. So Devesh, did you understand? So I think
Yeah, I understand, but it's just I'm gonna have to do a lot more of these problems. So
I'll send you guys some questions which use monotonic stack. I'll have to dig in. Maybe I might find it on maybe Medium or somewhere, some blogs. But or
Use a Skyscraper. They will get
but
many
I
problems.
never got Skyscraper before. Like using this one, right? I think you can also solve that stock prices question also.
Yeah, definitely.
Right.
Same logic.
I think. Yeah, I mean, Skyscraper is like it's like a hard question.
Okay.
Like, I've never even done Skyscraper. It's like very
stocks one is very common question. Yeah, that is also used to be
one?
common question. Yeah.
So basically, even if you get Skyscraper, right, the thing is you'll have to. I mean, I understand. So there was a question on stacks that Uber gave me, and also Amazon gave me. So Amazon, it was the hiring manager who gave it to me, and it was like tag validator. If you see on LeetCode, there's a question tag validator, but the question that the manager gave me, I couldn't even understand like what was going on. Only while discussing, okay, we can do this. Okay, this is happening. He was helping me figure out the pattern. He was see this dude. Once I figured out the pattern, then he told. So I did a conversation with him. Once I figured out the pattern, then he told, okay, can you code this up? Then in one go, I coded up, and he was like very happy. And it was a system that actually screwed me up. But all the interviews that I see, I think this is a common thing. That is, I mean, you have to. I mean, this Deven, you asked, right? How can you solve in 20 minutes? So you'll have to discuss it with the interviewer. And if the interviewer is not like giving you hints, I mean, it's his bad day. He might not get a good candidate. So his company is going to be screwed up now. So that is his thing. It has to be this has to be discussed by the interviewer. He has to give you hints, not hints, but help you figure out the pattern. And he'll be saying, can you figure out the pattern? So when I showed you this, right, initially that is decreasing. So we all came up with that. So we did the discussion. You guys came up with that. I did not. You guys came up with the pattern is decreasing. I did not. All right.
Okay.
I'll send you some questions, but this is a medium question on LeetCode. And if you go to the solution also, this is how to be coded. Maybe they might have, let me see what solutions they have. Because they'll mostly give you next array accepted. So this is n square, stack accepted. So this guy, right? So I'll just put it into the chat. So this is the stack. Can't I put everyone? So this is the Python. This is the Java. You guys can see. So basically, here also they use LeetCode. I mean, sorry, not LeetCode. Sorry, the same. So going from the end.
Okay.
So this is the Python. So basically, they go from the end. While stack is not greater than or equal to the t of stack minus 1, stack.pop, if stack, then you get the answer. Okay, now let me see. They have only these two solutions. First was the answer that Deven gave, which was brute force. This is the next question. Maybe next time he can like explain using even that concept that he gave. Maybe we can do a bunch of questions with that. So is everyone like okay with stacks now, where we use stacks? How stacks was useful over here?
Yeah.
Yeah.
People are not
I-
happy. I don't see people
No,
happy.
no.
I'm disappointed.
No, we got the concept, but I think, I think getting to the solution seems to be too tricky to me. I think the same question that Devin had, to figuring out the approach. I know the stack concept, but I was not able to come up with it. I think we need
So
to practice more.
basically, this is a question more on. So this question that I told you beginning, this is actually taught by IIT, like IIT to teach algorithms, and they wanted to teach stacks. What stacks are? This question was not supposed to be for lead code. They didn't teach it for lead code or for computer programming. They taught it to understand what stacks are, what stacks can be useful for. So we understood what monotonic stacks are. So this question, can I solve it in 20 minutes? That is something. Now you'll have to keep practicing on lead code. Like, where exactly can I use stacks? Where exactly? So that is why you guys are not not happy that I cannot solve this question in like 20 minutes, because it was a pure stack concept. Okay, so David, do you want me to take a lead code question with you next time for stacks?
Yeah, just post them in the
Or maybe I'll do one thing for all of you guys. I'll take a stack like lead code question only. Like, this was also lead code, but a question which is how would you solve it in an interview? I'll just stop the
Another thing, Ankur. Yeah, you can stop audio. One more session, right?
Yeah.